mechanical and aerospace engineer Philip Watts from California, marine biologist Frank Fish from Pennsylvania, and filmmaker and entrepreneur Stephen Dewar from Toronto. 3 men thousands of miles apart. So what connects them all?
We all love the sea, and we all love animals.
We're all interested in the relationship between biology and technology.
We all wanted to build something new and sustainable. We founded a company we called
WhalePower.
Efficient turbine blades, copied from nature. It was a chance occurrence over 35 years ago that ultimately led to the invention on which their company is based.
I was on vacation in Boston and went into this shop that had all this animal art. And in the center of the shop was a pedestal with a little figurine of humpback whales. And I looked at that and I saw that the leading edge of the flippers of the humpback had these bumps on them. And that made no sense compared to what I knew about fluid mechanics and just looking at airplanes. You always have a straight leading edge. And so I had to know what was going on with these whales and why they had these curious bumps.
From then on, the question really got him thinking. He watched humpback whales in the water. They glide and turn lightly and elegantly on their own axis, even though they're as large and as heavy as a bus. 7 years later, Fish had the chance to examine the flipper of a stranded humpback. He felt that the bump on the flipper, called a tubercle, was somehow related to the whale's swimming skills.
For the humpback whale, having the tubercles delays stall to higher angles, and so the whale can develop lift and thus turn tightly. If it didn't have the tubercles and its flipper stalled, it would be like driving on a road that's covered by ice. And when you take a turn, instead of following the curve, what would happen is you would go off tangentially.
He recreated the almost 2-meter-long flipper on the computer and also made an X-ray image. His hypothesis was confirmed, but how could he prove it?
And I went around to a number of people and I got some interest, but I never got much interest at all. And then what happened is I met this person, Phil Watts.
Phil Watts is not a biologist, but an engineer. A man who loves the sea and loves animals. With his expertise in mechanical engineering and in aviation, he was just the man for the job.
I had already been working in biomechanics, and so I understood the importance of biomimicry, about drawing engineering ideas from evolution. And when Frank shared that humpback whales were the only whales that had bumpy leading edges on their flippers, I immediately realized that that could have some important engineering consequences. So I ran some fluid dynamic simulations of wings with tubercles and wings without tubercles. And the tubercles increased the lift and simultaneously reduced the drag. And for an engineer who works on wing performance, that's a spectacular achievement to be able to increase the lift and reduce the drag at the same time.
Further investigations followed, now with several researchers involved. Soon it became clear that these were bumps with benefits.
Tubercles focus the flow between the bumps. And that focused flow helps keep the flow attached to the wing, and it also helps isolate the lift in between the tubercles. So if you have a bump here and a bump here, we're going to get a high lift region in between.
And what improved the performance in the water could also bring big benefits in the air.
And so what the tubercles do is they prevent the flipper or any wing from stalling. A stall is when the wing or flipper would lose its lift. Now, for a whale, that's not a big deal because the animal is neutrally buoyant in the water. So it's not going to fall out of the water. For a plane, if it stalls, then you start falling out of the sky.
The marine biologist and the engineer jointly published their research results. and they formulated a first patent for tubercle technology. 700 kilometers away, Canadian journalist and entrepreneur Stephen Dewar read about their work and was instantly captivated.
I was struck by the fact that this totally changed what we thought we understood about flow management. I was so taken by this that I tried to contact the scientists. So I called Frank and Phil, and we were talking about how this all worked. And I asked them what they were doing with it commercially. They called me back the next day and said, "Can we set up a company with you?" And we were off and running.
The WhalePower team developed prototypes and tested them. They measured 20% energy savings, improved efficiency, greater stability, and greater durability as a result. A second patent was filed, this time covering Europe, the US, and several other countries.
Our tests have shown that blades with tubercles are more energy efficient and quieter than standard blades. And so we can use this for applications such as wind turbines, fans, compressors, and pumps.
Our plans with WhalePower were to make designs and prototypes that could demonstrate the technology, which we would license to manufacturers. And that's what we've been doing.
From small fans for cooling computers to larger ceiling-mounted fans, retrofit models for turbines and wind farms, and much more. One is already under license, the others are planned for the future. Tubercle technology is both sustainable and unique, and it owes its existence to three men who were inspired by the secrets of nature.
From animals, we can learn so much. We just have to look carefully.
Tubercles are a technology for the future. They'll allow us to create a sustainable planet and allow future generations to thrive.
We were able to get an understanding of what was possible because nature had done so much work on this.
Malmö, a Swedish metropolis full of fascinating contrasts. Tradition and innovation. Water and land. Old buildings and modern architecture. And Malmö is where the young industrial designer Mehrdad Mahjoubi lives and works. Even as a student, he realized that he was more interested in what went on inside a building than in how it looked from the outside. How are we going to use our vital resources in the future? Water is one of our most important ones, so we must focus on it. All our buildings are permeated by an invisible and highly dense network of water pipes, the arteries that supply our cities. And passing through those pipes every second are vast amounts of purified water. Domestic consumption of fresh water in Western Europe is around 200 litres per person per day, for things like washing up, cooking and cleaning. In a city like Malmö, with around 300,000 inhabitants, that adds up to 60 million litres every day. One of the biggest wasters of water is the shower. Only 10% of the water gets contaminated by soap and dirt. The remaining 90%, heated and almost clean, drains away into the sewage system as so-called wastewater. So, we need to save water. But who would invent an entire shower to do just that? He did. A conventional shower uses more than 100 litres of water in 10 minutes, and then you also need 5 kilowatt-hours of energy to heat the water up to body temperature. Our shower needs fewer than 5 litres of water and less than 1 kilowatt-hour, because we recycle the water.
Just att vi återanvänder både vattnet och energin.
But just because saving water is the #1 priority doesn't mean the shower should be any less enjoyable, the designer says.
Det handlar inte bara om att göra...
This isn't just about creating a product that saves more water and energy, it also has to make showering even more comfortable and enjoyable. Here you can see that we use an especially large shower head with lots of water flowing through it, making showering as comfortable as possible. Interestingly enough, despite the large shower head, a great deal of water is saved. The trick? A closed-loop shower system. The interior is a cleverly designed recycling system, a kind of miniature wastewater treatment plant. The water flows from the pipe into the shower head. At the drain, a sensor checks 20 times every second to see if the quality of the water is sufficient for cleaning. If so, its recycling journey begins. A microfilter strains out larger particles, such as skin or hair. Another filter removes impurities in the nano range. Ultraviolet light kills harmful germs. Then the water, only a few degrees cooler at this point, passes through a heater, which warms up until it reaches a pleasant shower temperature. Purified in real time, the water is now even cleaner than that in normal taps and is ready for the next shower, again and again. The inventor's technology is a completely new approach. It's currently the most efficient shower system for saving water and energy in the world. Only contaminated water is exchanged immediately. The rest is recycled. To keep things hygienic, the filters are exchanged every 200 showers or so. The filters are easy to exchange and hold around 20,000 litres, so a family would need to replace them around 3 times a year. Majubi's shower system has already been installed in several hotels, as well as in hospitals and gyms. That is, wherever a lot of people shower, and hygiene is especially important. One of our first customers was a hospital. One day they had an outbreak of Legionnaire's disease, and all their water pipes were contaminated with bacteria. That wasn't the case with the showers we'd supplied, though, thanks to the closed-loop cleaning process in our system. Majubi's shower of the future is also smart. Water consumption and also service data such as filter changes are recorded digitally and can be easily monitored by users. One smartphone app, for instance, even shows how much water has been saved. The inspiration for Majubi's invention came from his time at university, when he studied space travel for a mission to Mars. How can you generate clean water without having to take gallons of it with you into space? I was involved in a project with NASA at the University of Lund. We wondered whether we could live under the same conditions on Mars as we do on Earth. Then I realized that we'd have to use our resources as cleverly as possible, and that's what we're doing here. The name of his company, Orbital Systems, is a reminder of that time. But Majubi's developments are intended for people on Earth. His inventions are the subject of several granted patents or patent applications relating to different elements of the system. Over 50 employees are now working on further development and distribution. So the shower system is becoming less expensive all the time and can be adopted worldwide. Since showers use up 1/3 of the water in a household, saving water with this technology is already having a huge impact in more and more markets. With rapid urban growth worldwide, water scarcity will become an increasingly urgent problem, impacting all levels of the population. And that is precisely why Mehrdad Majubi's shower is an invention for the future. Wind. It's an unlimited source of energy. But could we use it to meet the power requirements of the entire planet? We can try. A lifetime of trying began with a simple weekend trip to the seaside taken by a father and his 12-year-old son.
Det var stormvejr den dag, vi skulle ud og se de store bølger.
It was a stormy day, and we wanted to watch the big waves. When we reached the dunes, we really had to battle against the wind. You could just lean into the wind for support and almost fly along with it. I've never forgotten the sheer power of it. I had a feeling that it could surely be put to some kind of good use.
Egentlig kunne bruge til noget nyttigt.
His feeling was right. From that day forward, Henrik Stiesdal, who is now 61, devoted his entire career to wind energy as an engineer. He found a way of generating energy far out to sea. He developed rotor blades up to 80 meters long that were formed as a single piece. And he made climate-neutral energy available to everyone. But first things first. It all began on the family farm in Wilberg. They needed a solution. The farm's energy supply was growing increasingly expensive.
Efter oliekrisen i 1973 var energi blev meget dyrt.
After the 1973 oil crisis, electricity became very expensive. I was a student and felt there had to be a radical change.
Vi skulle have en
We needed a windmill that would provide enough power for the entire farm.
Jeg startede med at bygge.
So I started to build a small experimental one. After that, I built a wind turbine 3 meters in diameter, and we tested that. And finally, I built one 10 meters in diameter, and that supplied almost enough energy for the whole farm.
Alt det, som gården kunne bruge. Det her er den første vindmølle, jeg lavede.
This is the very first windmill I ever built. It's made of 2 boards glued together and cut into the shape of a propeller, and a 1 centimeter water pipe. So you hold it in your hand like this, and you can really feel the energy of the wind.
Now you're talking.
These experiments made him eager to continue. In 1978, Henrik Stiesdal designed his first commercial turbine.
Den skulle have 3 vinger.
It had 3 rotor blades. That was far better than the conventional 2 they had back then. The rotor blades were positioned at the front of the tower and aimed into the wind automatically. And the wind turbine also had a generator, so it could slow down in a light wind and run quickly in a strong one to achieve a maximum degree of efficiency. For the wind industry, this approach was a revolution. The classic designs until then had been based on propellers from the aircraft industry. Henrik's turbine with 3 rotor blades was far more stable and efficient, and it paved the way for the so-called Danish concept, the dominant concept behind the design of wind farms from the 1980s right up to the present day. The young Henrik Stiesdal kept on improving his turbines in the years that followed. It was in 1991 that he finally realized a mammoth project: the construction of the world's first ever offshore wind farm in Vindeby. Once again, he designed the turbines. And not only that, when the quality of the rotor blades failed to live up to his standards, Henrik Stiesdal came up with an entirely new concept.
Midt i 90'erne begyndte
In the mid-1990s, we had big problems with the quality of the rotor blades.
de vinger
At the time, they consisted of 2 sections, glued together, and the glue connection was the weak point.
limning, man lavede.
I concluded that the only radical solution was to dispense with the adhesive bond entirely, and to cast the rotor blades in a single piece instead.
Han ikke havde nogen limsamling. At man støbte vingen i et stykke.
And here's what his solution looks like from the inside. It's called integral blade, a rotor blade made of fiberglass formed as a single section. Up to 75 meters long, the blades sweep an area equal to 2.5 football fields. A true feat of engineering. There are no limits to Stiesdal's ideas, onshore or offshore. Even after officially retiring, he developed the TetraSpar wind turbine platform. And it's changing the industry's entire way of thinking yet again.
Konventionelle havvindmøller er begrænset til vand.
Conventional marine wind turbines are limited to water depths of 40 to 50 meters.
Offshore vind
That's why it's so hard to build offshore wind farms in, say, California or Japan. They need floating solutions there.
kan man bruge flydende havvindmøller.
Steesdale's idea is to manufacture the equipment on the coast and then to tow it by ship to its destination. There, the ballast tanks are flooded with water, making them sink. So the platform is not fixed rigidly to the seafloor, but anchored using cables. That saves time and money. Steesdale estimates that these floating wind turbines could reduce the cost of offshore energy by up to 75%. So, could wind energy really cover the power requirements of the entire planet? It hasn't yet. But if it ever does, that success will largely be due to Henry Steesdale and his inventions.